All right, here we are at section 9.4, which is all about the Pythagorean theorem. I think you guys know what the Pythagorean theorem is, but just in case, I'll remind you. It's a squared plus b squared equals c squared. So remember that a and b represent the legs of your right triangle, and c always represents your hypotenuse. This is going to be really important so that when you are given a triangle with a missing side, a right triangle with a missing side, you know which numbers to plug in where. Because if you plug them in the wrong place, you're going to solve and get the wrong thing. So if we look at this one, we're looking for one of the legs. So we have 8, which is A, let's say, and 17, which is C. So if we plug that in, I guess I called B x, that's okay. 8 squared plus x squared is going to equal 17 squared. So you just have to make sure that you don't put the 17 over here and solve for C. All right, so go through and solve this. Here we go, and look at that, we get x equals 15. Okay, so that's just the basics. You're going to have a lot of problems where you're going to have to solve using Pythagorean theorem. Look for those right triangles, make sure that you're plugging in the right numbers in the right places. Okay, but for the next couple minutes here, what we're going to do is we're going to take a look at a couple different proofs of the Pythagorean theorem. There are so many proofs out there, and a lot of them use many different methods. So one of the proofs our President Garfield, had come up with, which is actually kind of interesting. It basically goes under the assumption that you are creating this trapezoid with these two congruent right triangles. Okay, so this is a right angle here, that's a right angle here. These two segments are going to be parallel, those are the bases. And that the C, right here, this C and that C form a right triangle. Okay, so the idea is that if we wanted to figure out the area of the shape, the area of the trapezoid, it should equal the sum of the areas of these three triangles. So the formula for the area of a trapezoid, I know we haven't covered that yet, is 1/2 the height times base 1 plus base 2. And then we should recall that the area of a triangle is 1/2 base times height. So if we plug this into our formula, our height of our trapezoid is this entire segment, so A plus B. And then base 1 is A, and base 2 is B. So that's how I get these two binomials multiplied together. This is the height, that's base 1 plus base 2. Okay, so then we have to do the area of the three triangles. Well, this triangle right here, here's our base, here's our height, 1/2 AB. Second triangle down here, here's our base, here's our height, so 1/2 AB as well. Then if we look at this triangle, this is our base, this is our height. So 1/2 C times C, which is C squared. So at this point, now it's just a matter of simplifying both sides to see what we get. On the right side, we can FOIL AB plus AB, or A plus B times A plus B, sorry, and we get A squared plus 2AB plus B squared. On the right-hand side, what I'm going to do is I'm going to factor out the 1/2 and combine these together. So I get 2AB plus C squared. Now, if I multiply both sides by 2, I'm going to get rid of my fractions, which is always good. And now, if I subtract 2AB from both sides, look at what I'm left with, the Pythagorean theorem. Is that cool? All right, let's take a look at another one. This proof is based off of what we just did in the previous section, the altitude on hypotenuse. So let's skip the whole similar triangles coming up with proportions and just cut right to the chase. We've got these two formulas from the altitude on hypotenuse. What if I were to add these two equations, or subtract these two equations from each other? Well, why did I say subtract? I knew I was adding, and I wrote a subtraction sign. Okay, this is supposed to be addition. I was right the first time. I don't know why I wrote a subtraction. Okay. So when we add them together, we get a squared plus b squared on the left-hand side, and we get xc plus x, or yc on the left, or right-hand side. Getting my left and right mixed up, sorry. All right, so over here, they both have a c, so I can factor out a c, and I'm left with a squared plus b squared equals c times x plus y. Well, if we go back to our diagram, x plus y is also considered a c. So if I plug that in, I get the Pythagorean theorem. All right, there you go. Mostly, you're just going to be taking problems where you're going to have to look for the right triangle and solve for the missing side. Some of them are going to be easy, some of them are going to be challenging, so watch out. But have fun too.